So, next one is interaction force. What kind of interaction force? Why interaction force has come into picture? Then how to calculate effect of interaction force during collision time. Collision time is very small and collision forces, interaction force are large. Such large forces act during a very short interval of time. Therefore, it is an important point to analyze how they are going to affect. For example, when we consider a cricket bat hitting a ball, careful observation, that is slow motion picture of this in the TVs, when we observe during collision time, both bat and ball undergo deformation. That is, there is going to be deformation, ball and bat undergo. That is, there is going to be elastic forces come into picture and they will try to reform. That is, restoring forces come into picture, they will try to reform. Such forces means ball as well as bat will experience. Ball during collision time, first it will experience force in this direction, that is, bat is going to cause the deformation on the ball. Therefore, deforming force will act on the ball. Therefore, the ball in turn, elastic forces are developed, restoring the elastic forces, restoring forces are developed. Those restoring forces will try to reform. So, therefore, ball and bat experience forces. Those forces are variable in time, variable in magnitude, but direction is same. That is, the bat always exerts force on the ball, but during that time, contact time, the force is not of constant magnitude. It is going to be continuously varying. Therefore, time varying force in magnitude only, not direction. Such variable force acts on it. And also same way, bat is going to experience in turn an equal and opposite force on it. Therefore, this also time varying force. But time varying force acts during a very short interval of time. Therefore, the force graph, when we consider, force increases and then decreases. This time where Ti and Tf, when we plot a graph, this is a graphical representation of variation of interaction force with the time. In this case, what happens? This is the collision time. During this time, the interaction force increases to maximum and then decreases, drops to 0. After that, they are now separate, means during this time they are interacting. Area under the curve of this, that is what we call it as f dt integral. This is what we call it as impulse. So, therefore, cumulative effect of force and a short interval of time in which this impulse experienced. Therefore, we cannot calculate the force and time here, but its effect impulse we will be able to make use. Therefore, both ball and bat experience impulse. First, the ball will experience impulse of deformation in this direction. Impulse of deformation in this direction. After collision time, this is the collision peak. This is collision taking place. Up to this, there is a deformation. Next one, ball will try to come back to normal size. In that, reforming forces will come into picture in the opposite direction, that is elastic forces which are there in the body or ball, they will try to bring it back. Therefore, reforming forces will act, and this is impulse of reformation. Exactly opposite to that, impulse of reformation will be acting. So, impulse of deformation, impulse of reformation will be there, and which causes the momentum of the ball and momentum of the bat to undergo change. So, therefore, the time integral of impulsive force during collision time, we call it as impulse. Impulse is integral f dt, where f is the impulsive force and interval over which collision takes place, this is what collision time. Time integral of impulsive force over collision time, we call it as impulse. This is what is the consequence. Because of this impulse, what happens to the ball, what happens to the bat? Both ball and bat undergo change in momentum. So therefore, the ball undergoes change in momentum, also bat undergoes change in momentum. In the elastic collision corresponding to head-on collision, elastic collision, let us consider two bodies M1 and M2 interacting. Head-on collision case impulse is in this direction. Because of that, before collision, if they have velocities u1 and u2 before collision, these are the velocities along this line joining their centers. After collision, if the velocities of the balls are changed to v1 and v2, before collision they have u1 and v2 along this line. After collision also continue to be along the same line v1 and v2. And since before collision, after collision, they are moving along the same line joining the centers, in that case this collision is head-on collision, and momentum conservation tells us that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 vector equation. That is linear momentum of the first ball, linear momentum of the second ball before collision. This is total linear momentum before collision is equal to total linear momentum after collision. Before collision, after collision. This is the first equation has to be satisfied. Therefore, this is the first equation in the case of head-on collision. Now, if the collision is elastic, in addition to this equation, the next equation which is going to be satisfied is kinetic energy conservation. m1 u1 half m1 u1 square is the kinetic energy of the first body before collision, and half m2 u2 square kinetic energy of the second body is equal to half m1 v1 square plus half m2 v2 square. This is the kinetic energy of the second body. So these are the two equations which are to be satisfied. So this we can write m1 u1 square as u1 dot u1, I can write in vectorially involving vector values of velocities. Similarly, kinetic energy I can write u2 dot u2 is equal to half m1 v1 dot v1, similarly plus half m2 v2 dot v2. So like this we can write in this way or this way. Solving these two, that is solving for v1 v2 unknown velocities here before after collision, we will get expression for head-on elastic collision as m1 minus m2 by m1 plus m2 into u1 plus 2m1 u1 by m1 plus m2. That is what you will be getting as the velocity of the first ball, that is colliding ball, that is called instant ball. Velocity after collision depends on the final velocity, depends on initial velocity of the instant ball as well as target ball, depends on mass of the balls also. Next one, similarly by solving this velocity of the second ball after collision, means after being hit head on elastically, the second ball velocity we can calculate as 2m1 u1 divided by m1 plus m2 plus m2 minus m1 by m2 plus m1 u2. Just interchanging the subscripts, we will get this expression. This is velocity of the second ball after collision. These are the two velocities of the colliding bodies after collision. In what kind of collision? This collision what we have considered is elastic, head-on, elastic collision. In the case of head-on elastic collision, these are the values. So here various cases we can analyze. One, the masses may be same, masses may be different. So that we will consider in the next class. Here what we have considered today. First thing is what is meant by collision. Under what conditions an event in physics can be called as collision. Next one is what is meant by impact, line of impact. how line of impact decides the nature of collision, head on or oblique collision. The next one is how classification of the collisions is taking place. That is, type of collision is, should I start? Okay. The type of collision we can based on what? That is energy conservation, that is elastic, inelastic, plastic. In the case of elastic collision, linear momentum, in all these collisions linear momentum is conserved. Why the linear momentum is conserved? Because there is no external influence or external force involved in the time of collision, and because of that the linear momentum is conserved. Then based on the energy conservation, we have elastic, inelastic, plastic. Elastic collision where kinetic energy is conserved, just now we have seen. In the inelastic collision and plastic collision, kinetic energy is not conserved. That is how we have reviewed.